all 6 missions. You click on a mission, you go to Video Movie Clips. You'll see the different segments that they broke down into many tiny clips. I had to grab each clip and put them together. Here you can see the list of the clips, and I put them together and made a giant edit, which I analyzed. Here's a sample beginning. You can see the running time frame at the top. You can see the name of the clip at the bottom, and a segment, the part of the mission that is listed on the site, easy for reference, if you want to grab the clip and analyze it yourself, which I encourage you to do. Aside from that, there was remaining time frames of the clips for proper analysis. You will find out why. It's obvious that this is slow motion, and then sped up. You can see the timing that was changed and a factor at the bottom, how much the length of the clip was modified. Here's another example. You can see the time frame at the top, and now the time frame at the bottom. You see them running, based on the factor change. To the one at the bottom, it's not quite straightforward. There's quite a few different time changes they used. At the top you can see the name of the current clip. You can see the name of the clip on the list, how it corresponds to the clip list on the NASA site. Easy for you to reference. What I'm showing you, go to the site, look at the clip yourself. Do your own analysis, which again I encourage you to do. I will now briefly summarize the entire analysis. I will present clips to you, categorized by mission. Relay 11 has at least to offer, except for A12, the TV camera malfunctioned almost as soon as they turned it on. This is slow motion, hopping and jogging. It's quite extensive. Here I'm speeding it up. You will see more in the appendix if you'd like to see that the full extent. It's quite extraordinary. Notice the color changes in the footage that will be explained later, about how the footage was generated and supposedly acquired. This type of footage, slow time frame sped up, is very revealing, and almost the people get a clue that the footage is faked. Here we see an example, looks quite normal. Someone running on the surface. Seems reasonable, but when we speed that up, this is actual footage presented to us, and fairly obviously, it's slow motion. Another example seems reasonable. Look at the hopping, try to regen his balance, and here we have obvious slow motion again acquired on the surface. You'll see much more of that in the full analysis. They also walked on the moon, not nearly as much as running, or hopping, or jogging, that is, but I find that somewhat more revealing, and he looks quite normal walking, except for the pops, which will be explained later, again, just walking. This is sped up, you can tell by the factor change at the bottom. This is slow motion footage. And we will show examples. Here we change the length, speeding up, in other words, you can see that. It looks normal sped up, and slow motion. On the moon speed that it was presented by NASA, you will have to orient yourself to it. They are actually on wires, so that oddly to it, but still very revealing. This is spasms I noticed, quite having a few, and I suspect that it's because of the wires, but pulling them, throwing them off balance, so that they had to recover from their spasms. I had some extra events I found, so that I was very revealing when showing a modified speed. Here you can see the bottom, look at the time frame factor change. That's my analysis saying that it's normal, when there's no factor change, and this is what NASA presented to us. The gravity analysis. Here's lies prove the footage is faked. Gravity analysis of astronauts jumping is correct in NASA footage because of their combined use of wires and speed film changes. We will show quite a few examples of this. However, the analysis of falling objects and sand quite revealing. Falling objects and sand cannot be put on wires, so they had to film speed changes that were wrong to hide the gravity that was wrong, and they had few opportunities to make it look reasonable. Here you can see it's wrong based on my analysis on the moon. I modified the speed to make it look right, and you can see that the two compare together and the many factor change that shows that it's correct for Earth. This is one of the things. It was correct in the footage and wrong in my factor change. I realized I had the incorrect factor change for that one spot. We changed it just for the small portions so that the object is falling. You cannot tell. It plays clearly. Another example. It's wrong in my factor change. I modified it just when the object falls. You cannot notice. You have to see that the factor change at the bottom. Same analysis for sand. Lots of opportunities. Wrong in the footage. I modified by this factor at the bottom to make it look correct. And then my modification, factor change for the Earth speed. It is correct. And just don't have a few examples of this. Be prepared. And of course, you can look at the clip for reference and go analyze it yourself. Here you can see the astronaut jumping when the sand falls faster. Only a few examples where the sand was falling in the same. The astronaut was jumping, so I mentioned speed change quite a lot. There are speed changes events, which are the moon's multiplied speeds used in the clip. Here we see sand astronaut running away. Did you notice the fake that I used several speed changes? Here is an actual footage. It looks reasonable. He's moving fast, but watch. He will suddenly go in slow motion. That was presented to us by NASA. Here I found it because I used another time factor, he looks ridiculous, and then looks normal back there. Several different film formats were used in different aspects of the entire hoax. I believe the TV footage was actually captured on 16mm film, and then recaptured by a television camera. This is an optical printer, quite used extensively in the hoax, in different aspects, but an example of how a camera is pointed at the projector is projecting footage and the camera recaptures it at a different speed. Here we have an example of it. An A114 frames, slow motion, and then you can extract different frames at different patterns to create different FPS pieces of film. These are all the factors I have deduced were used in the footage. It's possible different ones were used, but I found that these good enough. This is a model of the set. It was used to capture the footage. You can see that a backdrop, very large moon surface reproduction set was used. Possibly 300 meters in diameter. This is an opportunity for enterprising science students to analyze the footage for themselves and deduce what size was in each instance. There was quite an extensive program conducted by Apollo to capture high-detail image of the landing sites. In fact, an intelligence service, NGA, has been developed out of this. Here's a Bell computer model of the surface using the footage, and I was quite accurate and extensive. Here we are, a POV of the set model. I am showing clearly how it had a backdrop. Analyzing photographs and footage captured by the astronauts and the TV cameras, we can see evidence of these sets that were used. We can find evidence for it the use of sets. These are panoramas provided by NASA, photographed joined as the astronaut danced in a circle. I call it the panorama dance. And actually, because of the overlap, we can also extract stereo images and analyze stereo images. We can also see that there is a point at which the set stops and the backdrop begins. And this is also because of the limitations of stereo photography allowed and not easily deduced as a set. Or it could be claimed as the limits of photography itself. As we further go, talking about the wires and in training, and the balance between counterweight versus frame speed. And when we analyze the footage, the test footage, it will more clearly match the modified NASA footage of Earth than it does the simulator footage that we see here. Because of the low gravity, friction was reduced, and you don't see much of that in the NASA footage. In fact, the extraordinary abilities granted by such low gravity are hardly discernible in the footage. And then we will look at the footage that somewhat reveals the use of wires. One wire at the top, there are the equations that show the counterweight necessary depending on the frames per second footage used. There's a lot of footage captured by the lunar rovers, photographs as well as DAC camera footage. Here we see the stabilized and sped up. It looks normal. The moon buggy looks like it's on an Earth set. Here again, it's sped up, and it looks like someone's driving fast on a set. It's also quite possible this was a model. More analysis will be necessary to determine which is which. But they had some fancy setups. With a simulator, sometimes on a set. An example here, you can barely see the lunar rover, the same model. There it is in the middle. They had a flight simulator setup with a complex modeling of the sun, matching the generated footage. And all of this is supported by NASA's capabilities, which we will show later. This is a model of a snorkel cam, and of a, quite possibly, they had stop motion animation with a camera inside a model. Look at how tiny that model is. And look at the footage generated. This is extraordinary stuff. I find it incredibly beautiful. This is John Dykstra, the mastermind behind Star Wars, who trained under the mastermind behind the Apollo footage, who I claim was the mastermind. But look at this incredible footage. That looks real to me. And this is all made from computer-controlled cameras and a tiny, tiny model. I believe they use larger models, the moon simulation of the Apollo hoax. But these tiny models show extraordinary results. And this is a computer-controlled animated camera. This is a fighter pilot flight simulator camera flying over a model. And they actually used the same technology to train the astronauts for the Apollo missions. That's a moon model with a flight simulator, live, real time. Flight simulator camera. This is actually a lunar rover simulator, same build. They had a camera, here it is, running over a model of the moon's surface, which they actually accurately modeled. The surface they would be driving on, they had two cameras, two views with one camera. And look at the camera It is going up and down as if the car is reacting to the surface. Quite incredible technology, not utilized there nearly as well as it was in the hoax. They had a complete setup, giant circular moon models, and they got more detailed for closer landing. This is all set up for simulated landing. They had a giant simulators. They utilized real-time cameras run over these models operated by the astronauts. This is an accurate topographic model of the moon, which is highly detailed. It was actually used in a simulator. You can see how large it is, and I believe this is a small compared to the models they actually used in the hoax. Here is an example of it being utilized in a simulator. These are just photographs from the simulator. They're quite extraordinary, and you'll reference footage later to see how easily that it was utilized. This is the man I believe responsible for the visual effects, Douglas Trumbull. I will show you the brief history. There's plenty of information on the internet about him. I just mostly wanted to introduce him. We have a landing footage. This is specifically Apollo 12. There was a dust blast. But on Apollo 14, they kind of screwed it up. You can see the difference in the lighting in the craters. Because before the dust hits, it's a model. And after the dust, it's the set. The lander was on. This is mission control. Very few there even knew it was a hoax. Only the astronauts were allowed. Only astronauts were allowed to talk to astronauts on the moon. They were all in on it, as well as the camera operator, because obviously the camera was recording, not live operated, and as well as agents. Only a few agents in mission control. Gravity analysis is, obviously, the most important, but I think some orientation is necessary if you understand what's going on when you look at the footage. A good place to begin is the moon's surface. Obviously no atmosphere or water, which of course means no plant life. The brightest photography, apparently stars aren't visible. No water also means no erosion. There's erosion disappearing. And of course, you end up with rocks and boulders and so forth. And craters, no craters in this view, but you can clearly see the simplicity of the surface also allows for the easier simulation of the footage of the landscape. TV cameras were used. This is a TV camera on the rover. It actually is quite large. You'll see some footage with this astronaut next to the camera, but it has used the rotating disc of red, green, and blue. And capturing 3 scans per frame, actually. And you end up with this kind of rainbow look to it. When all 3 colors are present at the same time fully, you end up with white. With none, you end black. Mixture of colors, mixture of intensity. Could give you gray of the colors themselves if they're separated. The slower it goes, the more you can see. The faster it goes, the kind of images, this blurry image. This is what today's film photography usually is made of. And television cameras are HD, and so they have a lot of this as well. Not as much as on the scan, as much as progressive, which is image after image. This is what many of you are used to at this point when you saw NTSC video. You would see odd scan lines. And even scan lines, and as the object moved, you see the separation. They call it combing. And this is an exaggerated version, so as you can see it more clearly. Sometimes there is a little blurriness, a glow, and a residual image, and so it softens a little bit. It's a little more bearable. But you can also see the style of motion blur here. If we have our simulated shot of the moon, you can see what it looks like. This is much more refined. You can barely see the scan lines here. This seems like it should have been the preferable way of capturing moon footage. but design demanded the hoaxers to use the progressive red, green, and blue. And that will become clear later. Here's that refined and with the glow and residual image. It provides this kind of trail that softens the effect. And of course, they have it simulated. There it is, just a shaky camera. Now we show rainbow motion blur. When we separate the colors, you can see what happens. This is a disc spinning, capturing red, green, and blue. Then the red, green, and blue are combined all three together. And we have white. Here you can see the different colors, and if you combine them in different intensities, you end up with the full gamut of colors in the rainbow, as well as in between. The closer they get to being balanced, the greater white and black it gets. And you saw the color footage. In the slow-mo, you see it again, quite often. That's because of the imbalance that was purposefully done. So now you see the rainbow motion blur. As the object moves, the red and green and blue are capturing different states of the object through its movement. When you combine them, you end up with separate colors. Except where they overlap, you get white the slower it moves. The more natural it looks, the faster, the more rainbowy it looks. And then we can add the glow effect, as well as the residual image. And you get something very similar. Here you get great examples in a few seconds of this type of footage. Here it's similar with video compression added on the top. So you can see, why does their image look so crappy? It was purposefully done to disguise it was on the moon, but it was only added to the hoax. Here are direct examples of the rainbow motion blur. The faster the object moved, the higher the contrast, white over black. It becomes very obvious, gray over gray, not so obvious. Some of these are looping, that's why you see them repeating, because they're just short clips. This is the full presentation. You'll see it throughout the analysis, except in a few cases, in which I have put them in the appendix so that you can see the full presentation of the clips. But in this case, there are a few enough clips that are showing the entire presentation that I think is advantageous, and then we will go through the specific examples at the end of the presentation here of the clips. I will turn some yellow and subdue them. They will not be utilized in this analysis. You can see the ones that I will analyze. Go back and take a closer look. Find which ones you like. Look at the smeary, distorted, crappy look. And, of course, those are my clips. Our factors changed except in comparison. This is the moon speed. This, I don't know, I'm not sure. Obviously, it's very slow. I just wanted to show you so that you can see the rainbow effect. We'll be analyzing thrown and falling objects. It's important for you to understand why what you are seeing. I cannot completely explain why. This is quite a complex pipeline they utilized to generate this imagery. It's 24 FPS was the actual speed, and then it was shown here in 30. That's what I have ascertained, acquired from the NASA site, 30 frames per second. So sometimes it just makes it very difficult to analyze, to reverse engineer. But we have enough control, that is, we can analyze the falling objects for gravity. There's a shimmery, otherworldly effect established, quite extraordinary. This is, of course, very slowed down so that you can see the effect. Here, sometimes you'll see it. It's compressed. Sometimes you see multiples. It's not very straightforward. We may never completely understand how they generated this imagery, but we have enough control to analyze for gravity, so that you can see the severe compression as well as distortion. Because of the white shovel over the darker gray background, the rainbow motion blur is more easily noticeable. And of course, the extreme movement. This is frame by frame. Why the specific changes are occurring, I do not completely understand. I have not completely analyzed for that. I do not see a need for it at this time. Then there's the camera's utilized lenses. There's distortion as a result. You can see this in the modern camera. That's cut in half so that you can see the glass inside. Lenses are curved. They're curved more extremely, less extremely. There's an array of lenses. This creates a complex, really complex situation of light moving through, and then you see the extreme curvature here depending on the lenses utilized. You end up with a certain amount of distortion. Here is a graphic example of distortion. This is a fisheye, an extreme fisheye, and this is the opposite. It is called pinch and push, I believe. And you'll find the footage. This is the kind of distortion that you can see. It helps disorient the viewer as well as it can make things look further away than they really are. Frames per second is a very important aspect of this hoax. You need to understand it, so take some time to understand it. A projector, this is how the film is run through the projector. The arm's grabbing the film, moving it along, and there's a spinning disc letting light through. You have reels of film, and depending on how quickly the film moves through the projector versus how quickly it is captured, you will end up with some effects, like slow motion and sped up. That's the DAC camera on the left, 16mm camera, and projector on the right, 24 frames per second. You move 24 FPS through the projector. As it was captured by the camera, you end up with a normal motion. 1 second, here's a 144 frame strip. And you can capture it all 144 frames per second if you want. That's quite extreme, almost never done, but if you do, 1 second of action captured at 144 frames per second, projected at 144 frames per second equals 1 second of action. However, if you project that same 144 frames at 24 frames per second, you end up with a 6 seconds of action. Because it's 6 times as long, the footage is 24 frames. That's extreme slow motion. Here's an example. There's 24 frames captured and projected. That's 144 frames of the bottom captured and projected out of 24 frames. It takes 6 times as long because it's only 24 frames per second, 6 seconds. This is accomplished by the optical printer mentioned in the summary. You have a camera pointed at the projector. It's projecting 1 frame at a time. The camera clicks, and you can skip 3 frames and capture another frame. And you can do it all in any portion, however you like. Effects were accomplished this way too. So here we have 144 frames per second film strip. We can fill those 24 frames with different frames from the 144 frame strip using our optical printer. You can see the pattern I used, the frames I used. This will give us different frames per second. You can recreate frames per second. You can recreate frames per second depending on the pattern you choose. And this is very significant in how this hoax was accomplished. There are all the specific frames per second that I have extracted from the footage that I believe were utilized. Here you can see the pattern of the frames, and the ones that have some in-between frames which you can use for the rainbow effect mentioned earlier. Quite extraordinary setup, and very efficient and effective. Here we see examples of those frames per second, playing at 24 frames per second. So you get different speeds of action. You could take 44 frames per second and play it at 24 frames per second. You could take 59 and play it at 24. How it was captured, or the speed it was captured or generated at versus the speed I played it at. Those are the factors of frame length. And these are the factors of frame length that were utilized, that I utilized, to reverse their slow motion, and made it look normal, as it was originally performed. You can see the 44 frames per second, it is the main film speed, and the others that were used in specific instances. Here we see them all, those frames per second, modified by the factors I showed. You can barely tell the difference, it's the same action, gone through a different process. And almost identical at the end of my process, my reverse engineering. You can see the subtle changes. So you could see subtle time frame changes used out of 144 frame film length, and so you can rely on the process I used to reverse engineer this action. Now the other complication mentioned was the fact that I was captured to 24 frames per second, yet shown to us and presented to the website at 30 frames per second, because that was normal NTSC frames per second. I did add some stuttering. The bottom of the 30 frames per second and at the top is also 30 frames per second. But I added stuttering, which you will find in some of the footage, and there's a phenomenon that I find quite interesting, is that the distortion of the footage, because it was broadcast from the moon, did some time changes where it actually went backwards in time and started up again, yet remained in sync. And that's a phenomenon that I think should be explored more, but of course I won't because it wasn't real. It will just confuse the viewer and make it think like it was coming from the moon.